So I'm going to talk to you today about a number of things. There's drama, there's romance, there's a bit of intrigue. Specifically, we're going to talk about cloud computing, software-defined networking, DevOps, the intersection of operational culture and what it means to us, how developers and security people are or aren't getting along as it relates to having a new operational model injected in their midst. That last talk, by the way, was just makes me want to not use the internet again. And in fact, if we ever talk about attack of the fonts, this is one way you can convey people to stop using Comic Sans, which I think is kind of funny. But by show of hands, in the audience, who is an actual or considers themselves a developer? Keep your hands up if you are a developer who have been annoyed by security people. Oh, look, they all stay up. Security people? All right, good, a good balance. All right. So as is usually my method of operation, I try to find something relevant to the place I'm talking. And yesterday I found out that Bing has won the amazing spot of replacing Google on the NORAD Find Santa site. And I mean, I found that interesting, Bing and Azure, especially when you consider the alternative, in which case Santa may have had a slightly LSD trippy-based present delivery. At any rate, let me define the problem, and I'm going to do it first by suggesting that what I'm going to position is a bit of developer versus security, but that's both the problem and the crux that we're going to highlight from an operational perspective as we go forward. And actually, it was very interesting. Two guys I watched simultaneously having a discussion online, kind of on Twitter on their blogs. One of them you may recognize, Mark Curphey and John Wielander, were having a conversation about developer priorities and security priorities. And they were using language to describe and kind of force rank how developers versus security people were paying attention in terms of what they were supposed to deliver. And they basically used the exact same language, but what you'll note is the all too common inversion of where security sits in the minds of those people, depending on what perspective you're coming from. Right? And that kind of sets up the crux of the talk. And I'm going to spend a bit of time hovering on the next slide, which is which kind of iterates around two schools of thought, one of which was posted rather nicely by somebody, an anonymous comment, which said, well, ultimately you're arguing about security, but security should just be this thing that exists as part and parcel of the development process. And that's a nice concept, but harder to do in many cases. I think we're going to explore a bunch of examples on how that's actually occurring today, thanks to things like cloud computing and the models that it introduces. But what I found is, as I listened to cloud evangelists, and in many cases cloud evangelists are developers in both small shops and large shops who are very interested in building new classes of applications and purpose-built for a particular cloud platform. It could be infrastructure, platform, software as a service, doesn't really matter. It's not really about migrating existing applications, because that's really a different basis for conversation. But a cloud evangelist will oftentimes argue that cloud computing and the cloud models are more secure. You have to ask then what, but more secure than traditional legacy enterprise applications. Security people will often argue that it's less secure. If you have the issue where, as we'll discover, we still have things like cross-site scripting, SQL injection, buffer overflows. How can I reasonably expect a developer to both deploy, manage applications, and ultimately abstracted infrastructure if we can't fix the most basic things in code? Evangelists will say, you know, the design precept here is the modification and change in thought process between building unreliable software on reliable hardware and flipping that model and building reliable software on unreliable hardware. And that model means that in many cases you'll find, if you're listening to Amazon Web Services, they say you should absolutely expect us and our service to fail. So that means your applications ought to be intelligent enough as part of the services we offer and what you design in terms of architecture to gracefully recover, to be resilient. The interesting thing here is if you talk about some of those applications and capabilities as being security-focused in nature, especially in highly compliant, highly regulatory influenced areas of work, you'll find that security is not only not rewarded, but never expected to fail. And that is a kind of a diametrically opposed perspective. You'll see folks say that cloud is more agile and costs less. Ultimately, you will see security people argue about the fact that at the end of the day, when something bad does happen, given the lack of visibility and transparency and integration, it'll end up costing you more to clean up the mess. You will hear what I call public cloud apologists basically say the only true cloud is utility-based models that are essentially today thought about in terms of commodity cloud. It's a terrible name, but you'll basically hear them describe every other cloud model and deployment delivery model as false cloud, which is an interesting argument. But the reality is, if you paid attention to any computing transition that we've had over the last 20 years or 30 years, and there's been several of them, you'll notice we end up with a hybrid model for obvious reasons. We have stuff on-prem, some stuff off-prem. The hybrid model wins overall. It lasts for a while, at least. And what was interesting is at breakfast, I opened up the Wall Street Journal this morning, and what popped up on my screen was this, an ad for Oracle Cloud. And what you'll notice is they're kind of advertising two different services, a public cloud offered in their data center, and then a private cloud that you manage. And the difference here, highlighted between the two, is that you have a firewall in a private cloud. Now, that's an interesting message to send, right, in contrast to what I just said about more or less secure. So I don't have a firewall in a public cloud. Well, you have a little bit of a different firewall. So this is part of the problem, is an imprecision in vocabulary and an approach in a different line of thinking. This is to make traditional security people feel good about themselves and that they can deploy and buy Oracle solutions and put it wherever they want. This is, well, trust us. And that's an odd discussion to have. As we go forward and we talk about the fact that in cloud-based operations, what we have now is the rise of DevOps or NoOps, where you have developers who are not only crafting the applications, but are responsible for managing, in many cases, the interaction of those applications on the platforms at which they sit. And it's a very non-siloed approach, very integrated. In fact, in what you'll find is that they have, as we'll talk about this a little bit later, small core security teams versus large teams that are very siloed. And what we have in the traditional world, where security people are used to operating, it's a very structured, compliance-driven, separation of least privilege, very stratified set of operations: network security, app security, info security, etc. The other thing that's interesting is in cloud, no matter which delivery and deployment model you're talking about, automation is really key. It's about kind of simplifying as much of the running of the platform and applications as possible. And availability is really the priority in many cases. In the case of a security perspective, abstraction yields this very complex simplicity, or simplexity as I call it. And system failures can get very, very muddled and dirty and large. The impact radius can be huge when we're talking about security, because one failure usually does not notify an upstream or a downstream that failure has occurred, and we will generally fail closed. So availability from a security perspective is secondary, as we found on the first slide. So the challenge we have is this set of divergent opinions between the operational models that cloud and developers have versus security folks. And so when I kind of dug a little deeper in terms of what I thought was missing, and this is going to come back at the end to kind of think about what the asks are, how we can fix things, how we can think differently. What's missing, I think, is something very simple, but is oftentimes not thought of appropriately, is there's a lack of instrumentation in applications that is inclusive of security. You may see auth failure messages that spit out some logging that Bob did not authenticate properly, but there's a lot of data that applications have within the context of what it is they're doing and how they're being operated upon that they could essentially export and allow either themselves or systems that are designed to protect them to operate more efficiently from a security perspective. The second thing is that intelligence and context, and this is an interesting set of dialogues you'll have with people, but because they have very, very almost religious debates here, is that the infrastructure layers and the application layers don't exchange telemetry in any meaningful way. And the case I made yesterday that brought up some interesting arguments is, in many cases, what I'm interested in is not just necessarily the application understanding if the infrastructure is under attack or vice versa. I don't even necessarily be desirous of the fact that one can control the other. But if you look at a cloud model, not unlike Amazon Web Services, you can be sharing a physical box with multiple neighbors, right? So Coke and Pepsi in the same box. And what has been illustrated time and time again is that Coke may be coming under a denial of service attack, which saturates the physical interface. Because you can't Pepsi can't put their interface into promiscuous mode, and you only see traffic designated to you, you are trying to figure out very quickly why your AMI is disconnected from your Elastic Box store. You can't figure out, what is happening. The infrastructure is currently under attack. The infrastructure knows everything about it, but it obscures and abstracts that capability and intelligence from you. Maybe what you would do, if the application understood that there was a difference between latency and causality due to not just degraded performance because of higher latency or lower availability of bandwidth, but actually the fact that something bad was going on, you could interact with load balancing functions. You could essentially have the applications be more intelligent about how they deal with both in-app as well as outside of the app, this particular consequence, and vice versa. So today, we just kind of, developers, give me a socket to talk to, I'll spit this thing out, I'll rely on some network services maybe, and maybe I'll move if I am able to detect or measure some latency, but there's no real communication from a security perspective. There's a lack of maturity in automation mechanics. That's both a good and bad thing. What I mean in terms of good is there's tons and tons of tools, lots of them. And the problem is in many cases they're platform dependent, or worse yet, they're specifically written in haste and or from the perspective of not thinking about how they will transfer from one platform to another. The real interesting thing is that over 20/30 years of network-based security capabilities, if you brought 10 mainstream network-based vendors up to a whiteboard and you asked them, can you please tell me how you instantiate a basic 5-tuple ACL, source, destination, service, action, etc., you will get 10 different answers, which is really kind of stupid when you think about just basic primitive ways of expressing and instantiating policy that we have been using for decades across platforms that ought to be able to do things better. So we kind of are looking at ways of how can we leverage these kind of de facto standards of security expressions and instantiation, give me a way of, on a heterogeneous platform, expressing security primitives so that I can attach policy to a workload, where a workload can be arbitrarily defined as a VM boundary, even an application or a service boundary, and no matter where it goes and where it spins up, I can call for this particular service. The operational security methodologies, ultimately, again, are still very siloed, and we don't think about how security can effectively transition the way we have artificially, in siloed IT, thought about who does what and where. And ultimately, as we'll see in a second, the fact that we still need SDLC, we still need sanitary application practices after all this time, in some of these cases is amazing. If we look at the Verizon DBIR every year, we see not so encouraging stats, like the fact that SQL injection is still such a huge problem, and that SQL injection through large enterprise-based web apps is responsible for such an enormous part of that problem. If we fast forward a little bit, the OWASP top 10 has not changed in 600 years. It's somewhat disappointing. And that indicates a whole lot of challenges that we have from a developer perspective, but also that from how we can effectively, from a security operations perspective, share some of this load in ways that make our security more intelligent. And as you see applications become more service-oriented again, what we find is that everything becomes accessible via API, whether it's infrastructure or applications. And the problem is that if you poll the majority of traditional security people, what you will find is they have a lack of understanding of protocols, APIs, development in general, the fact that XML, REST, SOAP, you name it. For the last 15 or 20 years, Gunnar Peterson has made the point, and I agree with him almost in entirety, that with every iteration of a new programmatic and development language and framework and compute cycle, the state of the art in security has been some variation of firewalls and SSL. It's true. It's our answer to everything. So we cycle between speeds and feeds, getting faster and faster, with the balance of the fact that in many cases everything we're looking at is encrypted and we can't do man in the middle, or we don't want to do full proxy termination. What we end up doing is, as I have this concept called the security hamster sine wave of pain, which talks about how we over time invest in security, and we just go waffle back and forth between host-based, application-based, user-based, network-based security. And we just bounce around every single time there's a new disruption, new innovation. We try to figure out how it is we're going to do things differently instead of solving the fundamental problems. So make this worse. Make this worse with the new advent of distributed, or the new version of cloud computing that has surfaced, and all of these new languages. So we used to have a few languages to deal with, ones that were well-versed. We even had security experts who knew about Java and C, etc. And we had ways of looking at both compiled and, in some cases, interpreted languages and making use of third-party services that do static and dynamic binary analysis. Well, now we have languages that you have to be Norwegian and not choke on your tongue to pronounce, A, and B, most security people haven't even heard of these languages in many cases, let alone know how to secure them. So as we complain as security people, developers say, well, if you only knew how to write code, then perhaps this wouldn't be a problem. Now, to be safe and fair, this next slide is a little shocking. It's actually a tribute to a very, very dear friend of mine, because when I released that slide and I previewed it on Twitter, I got a bunch of really interesting feedback. And one person gave me a lot of feedback. In fact, that lot of feedback translated into stalking me on Twitter. So, Barry Dorrance, if you would kindly stand up, this is my tribute to you. He badgered me 1,000 times to ensure that I mentioned ASP and Visual Basic and C# as the foundations of Cloud 2.0 and would not leave me alone until I guaranteed a tribute slide to him. So, Barry, by the way, I love the fact that your Twitter picture is basically a facepalm, so that's pretty good. So ASP, right. Anyway, onward. So what I did, welcome Barry, what I did was I started thinking about how I can talk about things in more tangible ways from a security perspective. And looking at the average age of people in this audience, usually when we go to developer audiences, I have to explain who George Carlin is. And it usually is like, oh, the guy from Bill and Ted's. I just want to die. So I'm just going to assume... I'm going to assume that you are old like me and kind of know who he is or just nod along. So George Carlin, he's kind of through the lineage of Lenny Bruce, and that's more than the guy in the R.E.M. song for those of you who are young, came up with 7 dirty words. And these 7 dirty words were words you could not say on television. Ultimately, he did and was actually arrested. But I started thinking one night I spent a large amount of brain power and an even larger amount of bourbon. And I came up with 7 dirty words of cloud security that just so happened to have the innate attribute that each one of my 7 dirty words starts with the same letters of George Carlin's 7 dirty words. So what is inevitably going to happen, as it always does, is as I start to go through them and try to be serious and focus, there are going to be people giggling like 12-year-old girls in the audience as they remember what the 7 dirty words are. So the first is scalability. The second is portability. The third is fungibility. The fourth is compliance. The fifth is cost. The sixth is manageability. And the seventh is trust. And these things kind of, for me, sum up a lot of the challenges we have between where developers are and where security people are and what this new model is doing to us, both from a technology perspective and operation perspective. So we'll go through a little bit of a tour of these particular elements, and we'll kind of circle back again as we explore all sorts of new and interesting things that are starting to disrupt the way in which we operationalize security, and we'll go back to those things that we're missing at the end, kind of wrap it up with a nice little bow. So scalability. This is a particularly interesting issue with security because distributed networking problems are tough. Distributed networking security problems are even tougher. For the most part, that is because security in the kind of firewall perimeterized model was never defined to scale at more than one point. And no matter how many times we've inflected between centralized and distributed, we end up coming back to the fact that, well, I'll just distribute more firewalls. And we've gone between doing it at the host level, which becomes unmanageable, to a speeds and feeds pick up again, thanks to the hamster sine wave of pain. We put bigger speeds and feeds at a perimeter. But now as the application architectures are more distributed, and not only in one data center, but across multiple, and they're distributed across mobile platforms at the exact same time, we're facing some really interesting challenges. Couple that with the fact that we have no easy way to take a policy at the infrastructure layer and unite that with a policy at the application layer that is not platform dependent. And we'll cover this more in a minute. But it gets more complicated also as when the back-end compute model goes from infrastructure to service, which for the most part just emulates smaller diameters of perimeters. I make the point that when people who argue that the perimeter is going away and it's dissolving, I disagree. I think the perimeter is multiplying, but the diameter is collapsing. So now we have thousands of micro-perimeters. Every service, every application, every construct, every VM is its own perimeter. And yet, what we don't have, even if we have commonality and standards for things like VMs, we still don't have a good way of expressing how we can describe the policy we want. I also see the very unfortunate kind of intersection of 3 laws. You got Metcalfe's law, which talks about the value and power of a network given the number of nodes that attach to it. You have Moore's law that talks about the number of transistors that doubles every 18 months. And then you have the unfortunate, and Josh Coleman came up with this term, H.D. Moore's law, which is casual attacker power grows at the rate of Metasploit. So if you take lots and lots of nodes with lots and lots of compute power, with lots and lots of script kiddies, that's bad news when you look at those other 2 issues, especially since the security, maybe for bulk volume-oriented attacks, we can deal with increased loads, but it gets more difficult as we go up the stack. And a lot of that is because security is not programmatic. We don't think of making declarative statements about security that can be implemented no matter where the particular workload or what the particular workload is. So The issue with security at scale is it doesn't. We rely and expect there to be a meat cloud, a bunch of operators who would somehow make a bunch of decisions about what does or does not happen as it relates to security disposition. When we think about what security means to us, when you get RFPs, even for software-driven firewalls in cloud-based solutions, they basically already start with speeds and feeds. It's the same old thing, just saying, well, I normally buy a security widget in a metal box, and now I'll buy it as a VM, and I may need more of them to make up the speeds and feed differences between what I can get out of ASICs, even though x86 compute capabilities are really starting to get amazing in terms of performance. But the problem is that speeds and feeds are only one part of this, right? If I don't have relevant context, policy, and state, it's very difficult. And ultimately, this whole notion of the self-defending application or network, insert name here, is made more difficult by what I alluded to before, which is as we have with cloud computing, the massive recentralization of apps in mega data centers. Just think of Azure, think of Google Compute Engine, think of Amazon, millions of square feet of data center. And we are kind of putting our data in less and less places, but with more and more compute nodes. We take that same set of applications and content, and we replicate them and or transform them, leave them either native or modified, and we're consuming them on all of these mobile platforms. So we don't have a good model so far to adapt to what's happening for infrastructure consolidation at the back end, and we sure as hell don't have a good model and a set of solutions for how we're going to be dealing with the mobility piece. The two of them together is a great perfect storm. So, by the way, when you look at solutions today, and if you're not sufficiently nerdy, that's me and Whit Diffie doing a public key exchange. Thank you. I worked hard at that. Most solutions today will tell you, oh, to protect your applications and data, this is simple. All you need is some overlay encryption and multi-factor authentication. Problem solved. Unfortunately, it's a little more difficult than that, especially when we have to take into consideration some of the things we're going to discuss. But this is what you see, is this kind of SSL and firewall a design pattern rearing its ugly head again. And that kind of N-tier, well-demarcated parameterized model just really doesn't work so well in highly distributed applications. To the point that when we start talking about portability, if we don't have consistency in standards and formats for workloads and service insertion across platforms, we're getting closer. It means we have a lack of telemetry in terms of what happens when these platforms are instantiated. And what they lead to is that what you see now is this huge push by network vendors because of the increased need for machine-to-machine communications at extreme low latency, whether you're talking about Hadoop for MapReduce, whether you're just talking about data centers where you want to be able to spread loads at what frankly ends up being layer 1/layer 2 across a flat fabric. As the networks get flatter and flatter, the ability for you to actually hook in physical, let alone virtual security solutions can be troublesome, because ultimately, on the one case, you have people making, and we'll talk about what this means in software-defined networking a little bit later, but you're starting to get to the point that where and how you instantiate security, even at a basic quote-unquote network level, is starting to abstract. To that point, abstraction has become a distraction. We've been so focused, again, on the introduction of hypervisors and virtualize this and virtualize that, and looking at that as an attack pattern because it's sexy, that we kind of get distracted by the fact that I still have to, when I move to an infrastructure or even a platform as a service, write secure code, right, and build resilient systems. So the funny thing is, if you look at the most basic examples, this is out of VMware's vSphere. It's the configuration XML file for the vShield app or vShield zones firewall, if you want to call it that. And the reality is it's not too alien. You could probably parse this if you're used to Cisco ACLs or Junos and not have too much of a problem. But the funny thing is that there's no human involved in the provisioning of this firewall. These are all done as part of XML constructs, quasi-programmatically. It gets even more interesting. In AWS, you have something that looks like an ACL, permit TCP from one IP address to another using that port. It looks like this API call to do that same thing in AWS as part of what Netflix does. And I'll refer to them a couple of times during this talk. Netflix is probably one of the most mature organizations that has folded in security as a requirement and an ownership piece of what the developers do, as well as a small core team. Everything for them is programmatic. So all of the security constructs, when instances launch and how they're deployed and ultimately how they respond to one another, have security built into the deployment methodology as part of their frameworks. And it's starting to get really interesting because they make use of security as a service, both external to the Amazon Web Services Cloud upon which they're deployed, but the majority of what they do is programmatic. And yet they have a small 5-person security team or so that really acts as advisors. And they're trying to move 100% of their operations, including all of their PCI and heavily compliant and heavily regulated compliant activities, into the cloud also. But it looks very, very different, and it operates very, very differently. So when we think about operations, we want to be able to make use and reuse as much of what we can deploy as possible. And so what this means is we need more and more programmatic ways of instantiating security. What's happening now is that security vendors are slapping on APIs to enable programmatic capability, but for the most part, what they've essentially done is added an API layer to allow their GUIs to talk over REST or SOAP. It's not really, there's no way for them to gain context of the so for example, I take a virtual appliance or a physical appliance and name a firewall vendor, and you slap an API on top of it. The reality is it knows nothing about the VMs that are being deployed atop it, right? Unless it has a way to tie into the orchestration provisioning system. So we're getting closer with these programmatic interfaces, but they're not reusable. They're very platform specific. So if I move from AWS to Google Compute Engine to Terramark service, I may or may not be able to reuse the same solutions. Few of them are API driven, and they're disconnected from the workloads they protect. And each level of the stack and the types of security solutions require different policies and different insertion mechanisms. And so if we take the most basic form of cloud today, infrastructure as a service, which looks very familiar, it's basically an abstraction of what we do in the enterprise today. It gets more interesting and complex, more opaque when you go up to platform as a service. But from a traditional security person's and operations staff perspective, it's very alien. It's interesting to note that more and more of this abstraction can be both a good thing and a bad thing. We can eliminate, as we'll get to later, entire classes of vulnerabilities. If you can stop humans from doing bad things by coding improperly, by eliminating that capability to make that mistake in a platform when you write your code to it, that's a net win. And we're going to see more and more of that as we continue to go up the stack. But before we go up the stack, let me focus on what's happening and what's being disrupted by technologies and operational models like cloud and virtualization. So the networking industry, the one in which I work, is undergoing a massive disruption in the form of software-defined networking. And software-defined networking is quite simply a way of separating the control plane and the data plane, or the forwarding engine. So you have multiple components in a switch. You have a management plane, you have a control plane which actually issues instructions, you have a forward plane that moves the bits around. So the interesting thing here is what you want is kind of a forwarding plane that can be more malleable, more programmatically influenced. If you wanted a certain feature in a switch or a router, you would have to wait for the entire code base for that switch or router to be updated for you to get that feature. And in many cases, the feature does not translate well from, let's say, an x86 Linux-based application you may run in a VM or on bare metal to running on proprietary ASICs or FPGAs. In fact, they may not have the memory space, they may not be the right architecture. So what you actually need in many cases is the ability to run services off the switch but tie it together. Do things like traffic steering, service insertion, service chaining. So the interesting thing is this abstraction, and this started with virtualization, where we ended up having a physical layer. We had and now have a virtual layer, an abstracted networking layer, which, by the way, is managed and operated generally not by the networking team. And the security for that runs in VMs or is exposed via APIs is also not managed by the security team. It's managed by these system administrators that ultimately own the keys to much of this castle. But what's interesting now is software-defined networking takes the physical layer, it takes the logical layer, and it overlays yet another layer of networking on top of that layer in a way of essentially distributing services in an overlay on top of what are classically defined as these underlay networks. And that's fundamentally disruptive because what you find is you can use cheaper and cheaper hardware in the forwarding plane as ASIC and FPGA costs or even x86 costs come down. And you can start building services and deliver them anywhere you want without actually having to logically, in terms of actually doing like layer 2 bump on the wire, or physically stitching a gazint and a gazaba cable together, you can tell a control plane, a controller, can tell a switch or a router or a firewall, actually, for flows that I think are interesting or meet these particular requirements because I've detected bot activity or I see particularly malicious behavior, instead of allowing this traffic to go from point A to point B, I want you to redirect to a honeypot. I want you to dump it. I want you to do route reflection so that I can do parallelization to an IDS or an anti-malware system. And that is done dynamically in a way that we haven't seen before. Fundamentally changing the way we think about what security and services and networking means. It's a really, really huge deal. And it's starting to happen both for service providers and the enterprise. Now, like cloud, SDN means a bit of everything to everybody. There's a ton of M&As, a ton of hype, but it really does hold a lot of promise. And for those of us that focus on the enterprise or even on the service provider markets, whether you're a platform provider or an enterprise provider, the reality is that you're going to see more and more of this impacting you as developers, because what SDN allows you to do is consume the network like a service. It goes back to the point I made before about having the infrastructure and the application layers interoperate and intercommunicate. You can't have a discussion on security without compliance, or as the Canadians call it, compliancy. And as we kind of all know that security does not equal compliance, but for the most part, if you're talking about mission critical and mission critical heavily regulated apps, security doesn't actually matter. Compliance matters. I can build amazingly and incredibly secure systems on pretty much any platform. They could pass any number of security audits, but some monkey with a clipboard is going to walk around and try to figure out how I comply to Section 6.6 of PCI, and if he can't interpret the magic that I've done, I'm not compliant, and I can't move my workload there. And so the interesting thing here is that we are running headlong into the fact that a lot of these compliance frameworks don't address emerging or disruptive innovation. And in the last 3 years, we've had so much of that. And you look at the cycles of something like PCI DSS, which is on a 3-year modification cycle for interesting, good reasons and really terrible ones. The problem is that we simply, in many cases, can't take advantage just from a general IT perspective, or better yet, from a defender's perspective, because we're not allowed to deploy these solutions. Meanwhile, attackers use virtualization and cloud and botnets and innovation and will absolutely exploit things like SDN for their ill-gotten goods, and we as defenders will have trouble with this. All right? So what this means is, how do we really demonstrate compliance for measurements that don't exist? And how do we ultimately, if something is such a dynamic environment, I can spin stuff up and down as quickly as I like, how can I leverage automation? Because we lack it today. How do I leverage automation to actually gather artifacts supporting my statements around compliance in such a dynamic way? I helped create an initiative called Cloud Audit, which actually uses a whole bunch of interesting Cloud Security Alliance aligned research areas to provide automated compliance gathering and enable service providers to make assertions and even allow consumers to decide whether or not a particular cloud or cloud platform meets their needs. But again, we have to focus here, and we're unfortunately shackled by what we can do based on compliance and not so much security. As we cover cost, whether it's bolted in or bolted on or built in, we're going to pay for security somehow. The reality is, whether you move to a CapEx model or an OpEx model, you're going to be shifting the operational nature as well as the solutions. One way or another, whether you use platform A or platform B, you're going to be able to do certain things and not do others, and the people doing them are going to change. Whether you're device or service-centric, the fact is that quality and stability, as you start to look at how you would traditionally use security and how it's being squeezed much more into the applications, means that it will cost you in the long run. And operational experience, as I pointed out in that silly language slide, if you're deploying in new application languages for which the security folks don't have expertise, you have two choices. You either potentially deploy insecure applications, or you have to go hire somebody else to do it. And that costs. When we start talking about manageability, security might be everywhere, but again, consistent management is not. This notion of managing devices versus managing services is still very alien. We don't really think about what that means and how it impacts our policies. It's managed by different people using different tools. And I'm going to show you more of this in a second, because every time we get a new delivery or deployment model, infrastructure, platform, software as a service, public cloud, private cloud, we kind of swing to what we know. And the challenge we have is that in many cases, the APIs and automation that we would like to use, most of us in the security space don't use a lot of automation. I was talking to Adam Shostak yesterday about how we can use things like recipes of Chef and Puppet to take design patterns and automate some of this capability. How we can use the same languages the developers are using and attach and insert security as a functional component of the development language. And John Ospaw, who is I think the chief architect at Etsy, said, a lot of people, and what we're finding now is some people, when they're confronted by a problem, just say they're going to automate it. And what you end up with is a 3 Mile Island problem, where when you get in these unchecked control loops, something bad happens, then you automate yourself into automated hell. And that's getting to the point that it makes it very difficult, if we're abstracted from that process as a security function, to help. The trust model issue is a bit funny. You can look at what the internet has done so far from the perspective of being quite resilient, and then you can look at every year we see some new formative chunk of our trust models, whether it's something like SSL, something like BGP, something like DNS, and it's starting to show stress cracks. But we're also kind of building our models for security in some cases, sadly, on the way we used to do things. And so adding more abstraction to a bunch of bad behavior means you have abstracted bad behavior. And the fact is that a lot of these platforms make these challenges more opaque. It makes it harder to essentially get to the point that security people, compliance people, operations people, developers build this sense of trust. And we don't have a consistent way of measuring this, which means we come up with this default perspective that we don't trust the cloud, which is kind of an obscene and absurd statement when you really get down to the heart of it, because really what this comes down to in many cases is this organizational complex. And there's another 7 words but besides the ones I mentioned, and they start with the same letter as those words, but some people forget that cloud concerns more than technology. This is so much to do about how the development and security operation teams get together and change the operational model. And this is kind of where this notion of DevOps comes into play. So when we look at the classical stack, and I assume cute little words to these things, infrastructure, metastructure, which are a bunch of protocols and abstraction layers, applistructure, which are applications, infostructure, which is data and information. If you look at just that kind of slice and dice of a traditional way of potentially kind of mapping to an OSI-like model, and then you look at how we manage security today, there's no discipline in our discipline. And what I mean by that is you will have different people at the infrastructure metastructure layer managing and providing different services to manage network-based security, host-based security, storage-based security. There are different teams, use different technology, different approaches, different policy. The AppSec guys use different tools, use different languages, are dealing with different problems, like morphing fonts from hell. The information security guys are dealing with how do I prevent exfiltration? How do I detect it? How do I ultimately understand where my information assets are and how they're being used? The notion here is that when you look at the consolidated view of next-generation applications in cloud, this is what DevOps really means. It's a way of taking these sets of security capabilities and being able to build them into the development and operational practices so that you have cross-functional capability, but maintaining the ability to troubleshoot, to show separation of duties, etc. So when I have the extreme privilege of being able to the Netflix guys are local to me. Adrian, their chief architect, is a really good friend I can ask all sorts of uncomfortable questions to. And I sat around with their security teams and their devs. And the interesting thing here is that when something goes wrong in Netflix, and they can do, using even an automated process and apply a process of automation, or to leverage where the breaking point was, the guy who gets to fix that is the guy that wrote the code. And the ticket comes to him. Now, we can call on other people for help, but there's a sense of ownership. And it's really interesting when you see these guys rolling code dozens, if not hundreds of times a day, and even rolling it back out to where you may or may not notice. Right? Same thing happens. You'll hear these stories about Amazon. You'll hear them about Google. But this model is fundamentally changing the way in which we have to think about how we operate. And it's almost in kind of maybe the wrong place to use this analogy, but it's the Apple II versus Mac feud. If you ever watched that documentary about Silicon Valley, where the Mac guys came in and flew the pirate flag and said, "Don't worry, we're here to save the company." Meanwhile, the Apple II guys were generating all the cash for said company. It sets up a really pissy and confrontational attitude. Right, where you've got a bunch of today, you've got a bunch of folks that we even have it in the enterprise. You've got the traditional network and security folks and operations and system admins. You got the guys who have over the last 3 to 4 years now kind of spun up and owned virtualization, which uses those other features and functions in their eyes as a commodity. And now you ultimately have these cloud architects who are taking that to a whole nother level and dealing with scale. And so that disconnect kind of comes from the fact that it's a very interesting model. Connectivity, when you think about it, distributed connectivity is what drove us from the centralized model to a distributed one. If you remember way back when with mainframes, Programmers did it all. The guy who ran the mainframe programmed it, was in charge of the hardware, in charge of security, cleaned the thing, changed the tapes, did everything. And in fact, what's interesting, we got more siloed as we got more distributed. And the funny part about that is most of us that came from the network and security background came from that same background where we did it all. And now we're like yelling, get off my lawn to the same people that want to do the same thing in cloud. Most DevOps guys don't have big security teams. It's not a religious discussion. And what it means is ultimately, as we progress through this next 3 or 4 years, we can't afford a turf battle. Right? This really isn't the West Side Story. As I like to say, besides security guys have better knives and developers have better dance moves. So the point is we have to kind of think very, very differently here. But it's not to say that not everybody can be a Netflix or an Etsy or a Zynga or a Microsoft. And not everybody needs to be, but they should aim for looking at the best practices operationally. And what's funny about the statements I made, at least it's funny to me, it wasn't funny to the executives that I talked to yesterday, but my wife did her postdoc geophysics studies with a professor named Walter Alvarez, who came up with a theory that the meteorite impact in the Chicxulub crater in South America basically hit with such a large impact, the pyroclastic ejecta filled the sky, blocked out the sunlight, killed the plants, and then killed the dinosaurs. Right? It's called the KT event. KT stands for Cretaceous Tertiary Boundary, 65 million years ago. She did a bunch of core sample stuff. So I look at this as a generational issue. Basically what that means is for cloud to be successful to the point that it needs to be in the enterprise as well as public-based cloud, they're essentially waiting for us to die off. They're waiting for the dinosaurs, as I was reminded I was basically implying yesterday, to essentially go. So those of us that came from the background of doing it all, that now are managers with budgets and are yelling at these kids that that's not the way we do things here. The interesting thing is, right, these are people that come to work, grow up, text, don't talk on their phones anymore, basically expect that this model, they've never bought, never will buy a server in their life. This model is what we have to get used to. And so when you think about it, the client server kind of broke out our computing models. So we went from mandatory to discretionary access control. We went from secure operating systems that were single user to multi-user distributed. Now we got mobility. Cloud really kind of, especially when you go upstream to platform as a service, re-centralizes those services. So kind of kernel mode is your platform, your cloud platform, and user mode is a web browser. Now, that's both good and bad, especially given the talk we just had, where that user mode is now being exploited in really, really rude ways. So this re-centralization is both interesting and makes for a giant, juicy attack surface, but also helps us potentially solve a lot of problems. And platforms are really the interesting differentiation here, which is today, security teams are invested with dealing with kind of protecting applications and infrastructure with more infrastructure. Developers secure and build and secure their software with more software, and that's really the problem. We have to enroll security in the problem and make it part of a shared and community effort. To that point, if you look at what Netflix does, they take all their code and they open source it. So you will see this notion, you'll hear chaos monkeys. They have something called the Simian Army. They have code that legitimately at random periods of time goes out and shuts down random pieces of their infrastructure without telling anybody. And they see how it responds. And they fix it, and they learn, and they iterate it, and it doesn't happen again. They have the security monkey that's going to do the same thing. Turns off security. I dare one of you to run into your data center and turn off your main egress firewall right now and see what happens, right? If the culture isn't there to support it, well, don't. That wasn't open there. The point being, actually it'd be kind of cool. I'd like to see that. But the point is, if we don't kind of think differently about what the technology and operational models mean from a conflux, we're going to see a whole bunch of crap. More FUD, more uninformed people, more dinosaurs making bad decisions about how we can really leverage this new technology in interesting ways. Vitaly Osipov made a really interesting quote, right? Ignorant and self-righteous security teams can be more dangerous than attackers. Amen. If I ever had to call the help desk or security team, and I was one, I remember my attitude is very different than it is today. I think we can change that. I think ultimately if we think differently about how, where, and why we apply security and be part of that solution, it can be good. So let's do a better job by focusing on trying to add, as you go forward, as your programmatic models for how you operationalize security goes forward, add these things. Instrumentation that's inclusive of security, intelligent context sharing between infrastructure and applications, the ability to precisely and as a community and an industry define how we deploy and operationalize security. And basically, let's help in the rest of the context of these talks fix some of these silly human tricks that we make and mistakes. We need developers to participate in the Cloud Security Alliance. We're very infrastructure focused. We don't have a good development perspective. The CSA has been around for 3 or 4 years. We've written an enormous amount about how we can help securely both author new applications and move applications to the cloud. But that's from an infrastructure and a security guy's perspective. We need developer input. Please visit that and contribute if you can as a community effort. If we don't, it's just going to be holding us back from actually being able to do things and focusing on the things that really matter. If you're interested, and I really appreciate the amount of time you've already spent listening to me rabble on, there's a whole other series of presentations going back 5 or 6 years that started with the virtualization all the way up to the last one, Commode Computing, which features a 9-minute and 38-second 3D fly-through of the history of toilets and what it means to security. It's fascinating. I recommend it. But anyway, I am out of time. But thanks so much for listening, and I hope this gets you thinking differently about security, development, and operations. Thanks a lot.